Our problem is a boy kicks a can with an angle of 20 degrees and with a velocity of 30 meters per second. Find the time of flight, maximum height, and the range of projectile. First, we need to write the given values. The given values are the initial velocity of 30 meters per second and the angle of 20 degrees. Then we need to draw the illustration of the problem. Boy. And the trajectory of the can. This will be the initial velocity, then this will be the angle, and we need to find the v sub 0 x and the v sub 0 y, or the initial velocity of x and initial velocity of y. The initial velocity of x formula would be initial velocity cosine theta is equals to 30 meter per second times cosine 20 degrees. The answer would be 28.19 meter per second. Now the initial velocity of y will be v initial velocity sine theta is equals to 30 meter per second times sine 20 degrees is equals to 10.26 meters per second. We can use a derived formula for computing the time. T is equals to 2 times initial velocity of y over g. Then time is equals to 20.52 meter per second over 9.8 meter per second squared. Divide meter per second, 20.50 time is equals to 2.09 seconds. Now we have the first value, the time. Now we need to find the maximum height. To find the maximum height, you need to write the formula h is equals to initial velocity times sine theta squared. Compute 900. This will be the initial velocity squared would be 900 and over 2g. I forgot the value of gravity. Then 900 times the sine 20, 0.12. We will raise this to squared over the value of gravity 9.8 times 2 is 19.6. And the answer would be 5.37 meter. Then last one is the range. To find the range, we need to write the formula r is equals to initial velocity squared times sine 2 times theta all over the gravity, the value of gravity, equals 30 squared times sine 40 over 9.8. R, the answer would be 59.03 meters.